Hello, this is Dr. Mears. Today we are going to be learning about tree diagrams. Tree diagrams provide another way to represent and calculate probabilities. Example 1. Two fair dice are rolled. First a big die is rolled, and then a small die is rolled. Don't know why I did those voices, but let's look at the big die. Here's the big die. It's so big it doesn't even fit on camera. Look at that big die. Anyways, it has 6 sides and it's fair, which means each side has an equal probability of coming up. Now let's look at the small die. Look at that small die. Again, it's a fair die. It has 6 sides and has equal probability of each side coming up. All right, so what are we going to do? We need to draw a tree diagram, but I need to know what my wins and losses are. I need to know what the heck the problem is about. But I wanted to start with a tree diagram because I needed to show you what it looks like. So let's actually just go to the questions to see what we're going to be working with. We're working with double sixes, no sixes, exactly 1 6. Okay, so we're looking for either a 6 to come up or no 6s to come up, which are the other sides. So we're going to base our tree diagram on whether or not we can roll a 6 or not. Okay. So for our tree diagram, what we're going to start with is we're going to start with a big die. Remember that big die. Okay, so here we have our big die, and we have two possibilities that's going to come up. We're either going to get a 6 or we're not going to get a 6. And so now on our die, we have 6 sides, and there's only one side out of those total sides of 6 that a 6 can come up. So that's it. The other 5 sides have no 6s. So our probabilities for rolling a 6 on the big die is 1 out of 6, and rolling a 5 and no 6 on the big die is a 5 out of 6. So now let's say we roll this die, okay? And you can't really even see it. So this is, you're going to have to take it for my, take my advice. This is a 6 right here. So let's say on the big die, I rolled a 6. So I'm looking at this branch right here. From this branch, what I'm going to do is I'm going to roll my small die. And on my small die, what I can have come up, oh, there it is, I can have a 6 come up. Again, it's going to be either a 6 or no 6. So now my 6, there's only one side that has a 6 on it. All the other sides don't have a 6. Okay, so let's say that I roll my big die, and let's say just 1 comes up, which means I'm going to this branch right here, no 6. So from there, again, I'm going to roll my small die. And I could either roll a 6 on my small die, or I can roll not a 6. And again, it's going to be 1 out of 6 or 5 out of 6. And there's my tree diagram. Welcome. We are now representing probabilities using tree diagrams. All right, let's go find some probabilities. So the first probability that I want to find is double 6. So now for a double 6, what we have to do is locate the pathway that brings us to a double 6. So first we start here. Here I am. Okay. That's as good as I get. So I'm going to roll, and first, in order to get a double 6, I'm going to have to go on this pathway right here. And I'm actually going to change pens. Okay, so double 6 is here. I have to roll a 6 on the big, and then to get a double 6, I have to jump over to this branch here. So I'm going from branch to branch. So what's happening is I need an and. And when we do and, it is multiplication. So that's a little multiplication here because I need to roll a 6 here and I need to roll another 6 on the small. And so when we do that, our probability is going to be 1 out of 6 times 1 out of 6 because I need the 1 out of 6 first on the big die, and then I need a 1 out of 6 on the small die. And when we multiply those, we get 1 out of 36. And you can simplify that down to, and I'm rounding, 0.028. On your probability project, you're probably going to want to say the chance of it happening, and the chance is about 2.8% chance, which is very small. So we took this pathway. We need a big on the 6 and a big on the small. We jumped from branch to branch, and when you do that, this is going to be 1 out of 6 times 1 out of 6, which is 1 out of 36. So that's this pathway right here. Some people may want to make their pathways already and start with the multiplication. You can do that as well. Okay, let's see what's next. No 6s. Okay, so now I'm going to have to find my pathway for the probability of no 6s. So the first thing is I roll that big die, and here's the no 6 right here. Okay. Well, from here, from my no 6s, and, which is multiplication, I'm going to have to jump to this branch right here where it's no 6 on the small die. So my pathway is no 6 on the big and no 6 on the small. So what we get is we're going to get 5 out of 6 times 5 out of 6, which gives us 25 out of 36. And that's going to reduce to 0.69. So we have about a 69% chance that we're going to roll no sixes, and that's pretty good. So this pathway here is 5 out of 6 times 5 out of 6, which is 25 out of 36. Now, if you wanted to go and make the other pathways, you can. However, we're going to fill it in when we do this next one. This next one is exactly 1/6. So we have to find all of the different pathways to get to exactly 1/6. So let's first look. Okay, here I'm going back. We need exactly 1/6. So I'm going to roll the big die. So here's my big die, exactly 1. So if I roll a 6 on my first one, I have to go to the path of not rolling a 6 on my small one, because remember, I need exactly 1. So my probability here is 1/6 times 5/6, because I need both of those to happen. So let's write that down. 1/6 times 5/6. All right, so that's one pathway. Now, we are going to be jumping to another pathway. So let's look back, because I could now do a pathway where on the first one I don't roll a 6, but I'm still in the game because I just need exactly 1. So on the small die, I'm looking to roll a 6 right there. So I need no 6 on the big and yes 6 on the small. So let's multiply those. So here I have 5 out of 6 times 1 out of 6. Now, if you're jumping from pathway to another pathway, we're doing an OR. When we do OR, we have two different paths to choose from. Therefore, we are going to add. When you have two paths, you add those two probabilities together. It's even better. So here we go. 1 times 5 is going to be 5. 6 times 6 is 36. These have common denominators, which makes it really nice. Again, 5 times 1 is 5, 36. So this is going to be 10 out of 36, and that reduces to about 0.28. So that's the probability of exactly 1/6. Now let's fill some of these in. So we did this pathway here. We did big to small, and so we got 1 out of 6 times 5 out of 6, which was 5 out of 36. And that's what I wrote down here, 5 out of 36. Okay, and then we did the other pathway to 1/6, 5 out of 6 times 1 out of 6. So 5 out of 6 times 1 out of 6, and that gives us 5 over 36. Okay, so these were the two pathways that we took here, and we just added these two pathways together. So some people like to actually do this multiplication out to start when you do your tree diagram. That's absolutely fine. Some like to fill it in like we have done, either one you want. Okay, let's go to the last one here. Oh, not the last one, sorry, we have two more. Probability at least 1/6. At least one. So that means one or more. So we're going to have a couple different pathways to choose from. So let's look at the one or more pathways. All right, so this warrants another color to make it even darker. All right, so we need at least 1/6. So let's go for the big. Let's say I roll the big, I roll a 6 here. Okay, and I roll another 6. That's absolutely fine. That's 2 6s. So rolling 2 6s is fine because that's at least 1. So I'm going to be doing this 1 out of 6 times 1 out of 6. So this is my pathway that I'm using, which is 1 out of 36. And we can 1 out of 6 times 1 out of 6, which is that 1 out of 36. Or I'm just simplifying it down here. Please do not be confused. These are the two branches that lead me to this path. Okay. Or let's look, we need at least 1. Well, on my big one, I could roll a 6, but on my small one, I might not roll a 6, which is fine because that's at least 1. So I'm now looking at this pathway right here, 1 out of 6 times 5 out of 6, which is 5 out of 36. So let's just write that down. Or I could do 1 out of 6, 5 out of 6, which is just 5 out of 36. You do not have to show all of this work. I'm just showing you because this is your first time learning it. Or there's another pathway where we can get at least 1/6. So we can do at least 1/6. On the big die, say I roll that big die and I get no 6s here. That's absolutely fine because I still have a chance to get at least 1 because I could get 1 on the small. So now we're looking at this pathway here, 5 out of 6 times 1 out of 6. So let's write that down. 5 out of 6 times 1 out of 6, which gave us 5 out of 36. Again, I'm just simplifying it here. Now, because I have common denominators, I can keep that common denominator and add the numerators. 1 plus 5 is 11. 11 out of 36 is 0.31. So I have about a 31% chance. So let's just look. I have 1, 2, 3 pathways that I could have taken to get at least one. This was my first pathway, this was my second pathway, and this was my third pathway. Okay, let's keep going. The last one for this tree diagram is going to be the probability of rolling a 6 on the big one given, that's what this line means, at least one 6. So what's in back of the given is now going to be set as our denominator because that's what's given. The probability of at least one 6. Now we found that here, so I'm simply going to write that down. I now have my denominator. So that's all set. So now in the numerator, I'm going to have to get the probability of a 6 on the big, making sure I get at least one. So what's going to happen is to get a 6 on the big, I need 6 on big, and I need a, let's say, not 6 on 6 on big, and I can get a 6 on small. That's 6 on big. Or I can get a 6 on big, and I can get no 6 on small. So there's going to be two different pathways. If you like writing it out like this, again, I'm just giving you little clues on how to write it out. So let's go find the probability for a 6 on big. So let's go up here. Okay. So first pathway is this one right here, 6 to another 6. So that's going to be 1 out of 36. So it would be 1 times 1 out of 6, 1 out of 6. Or there is another pathway that I can do. It's still getting the 6 on big. However, I might not roll a 6 on the small, which is fine. So it's this pathway right here, 1 out of 6 times 5 out of 6. 1 out of 6 times 5 out of 6. Okay. Simplifying this, instead of writing this whole thing, I could have simply added these two together. That's fine. So adding these two together because they're different pathways, we're adding different pathways. This really comes out to 6 out of 36. And we are going to be dividing by 11 out of 36. You can do this in your calculator if you want. However, the denominators do cancel out, and we get 6 out of 11, which is going to be 0.5454, so it's going to be about 0.55. So we have a 55% chance. That's not too bad. Okay, that was your introduction to tree diagrams. Let's look at tree diagrams with replacement and without replacement. All right, so I'm going to need a new sheet. So here we go, because that marker went through. All right, tree diagrams, flipping it over, with replacement and without replacement. So when you play games, you have to make sure, are you going to be replacing cards back or are you not going to be replacing cards back? So the game that we're playing here is going to be with replacing cards back. We have one card in a bowl. We have 8 cards in total. So some, my little leaf bowl, hey leaf, we have 8 cards in total. 6 are going to be black cards. 1, 2, 3, 4, 5, 6 black, and 2 are going to be red. 1, 2. So turn them around. I'm going to shuffle them. Shout out to Mohegan Sun there. Maybe they give me some money. I have to win it. All right, so we have 8 cards, 6 black, and 2 red. 1 card is pulled. The color is recorded and placed back into the bowl. So I'm pulling a card. I record that's a black card, and then I put it back into the bowl. And then a second card is pulled. Again, I record the color. Ooh, another black card. And then I put it back into the bowl. So that's called with replacement because you're actually replacing the card back in the bowl. Let's draw a tree diagram. Let's look to see what we're going to need to do it on. One of each color. First card is black, given 1 card is of each color. So what we're looking for is this. We're going to set it up. We're going to have our first pull of the card, and it either could be black or it can be red. And then from there, if I pull a black card, I'm going to do the second card. And the second card either is going to be black or red. If I pulled a red card here, then my second card could either be black or red. So that's just setting up the skeleton of the tree diagram. Let's put in our probabilities. So black cards on my first pull, I have 6 that are black and 2 that are red. So 6 out of 8 are black, 2 out of 8 are red. And then my second, I'm going to replace it back in. So that means I still have 8 cards. So my denominator is going to be 8. I still have 6 black and 2 red. And the same thing here. 6 are going to be black and 2 are going to be red. So basically it's the same probabilities assigned to each branch here. because I'm replacing the cards, which means my denominator will not change. I still have the same amount of cards. Let's do part B. One of each color is pulled. They want you to find the probability. So now what we're going to have to do is look to see the pathways. So one of each color. So here I am. So let's say that I first pull a black card here and one of each color. So that means I'm going to have to pull a red card here. So the pathway that I'm taking is 6 out of 8 times 2 out of 8. So 6 out of 8 times 2 out of 8. And that 6 times 2 is going to be 12 out of 64. Okay, so that's one pathway. Or there's going to be another pathway. I could have pulled a red, which means I'm going to have to get a black because I need one of each. So this is going to be 2 out of 8 times 6 out of 8, 2 out of 8 times 6 out of 8, and that's going to be 12 out of 64 as well. When I add those together, I get 24 out of 64, and I've actually already simplified this down to 0.38. And what you could do if you want to just write these here, it's just another way of organizing it. So you could have just taken these two and written them down and then done your math. Okay, what's the next one? First card is black, given one of each color is pulled. So they want you to find the probability first card is black, given the probability one of each is pulled. So remember, this is now going to be our denominator. And one of each. Oh, I just found the probability one of each. That's right here. So I'm going to write down 24 out of 64. If you want to write the reduced decimal, not the reduced, the divided out decimal, that's fine. I just want to show you how the denominators cancel out, which is kind of cool. Okay, so that's the denominator. Now the numerator is going to have to be first card is black. All right, so first card is black, given one of each color is pulled. So let's go up here. So the first card is black. So here we are. This pathway, the first card has to be back, given one of each is pulled. So I'm looking at this 12 out of 64 here. So it's going to be first card is black, one of each color is pulled. So I'm going to get 12 out of 64 over 24 out of 64. You can either do the decimals, however, the denominators, 12 out of 64, 24 out of 64. I missed the page. The denominators cancel out. This leaves us 12 over 24, which is 0.50, which is kind of cool because, I mean, it's a 50% chance. Okay. Let's go to the next one. The next one is without replacement, and without replacement is going to be not putting it back in. So here we have our cards. I take one out, I record the color, it's black. Now I take it out. So what has happened here? How many cards do I have now in total? 1, 2, 3, 4, 5, 6, 7. I only have 7. And if I take a black out, guess how many blacks I have left? I only have 5 blacks left. 1, 2, 3, 4, 5. So what happens when you don't replace is that you're going to have less cards, and you have to make sure that you take into account which cards are not being replaced. So one card is pulled and the color is recorded and not placed back into the bowl. A second card is pulled and the color is recorded. So we have to draw a tree diagram. When we draw the tree diagram, we're going to do the same thing right over here. So here's our first pull, red, black. Okay. From here, we're going to do our second. We could do red, and we can do black, and from here again, what's S? What is that for? That was for second. Red, and black. Okay, so your first pull is fine. We have 6 out of 8 for the red, and we have 2 out of 8 for the black. Now here's the thing, I don't put them back. So let's just work with one branch at a time. Let's work with this red. So I'm standing there, I pull a red card out, and you know what I did? I did this backwards. My bad. I'm trying to go too fast. Teachers make mistakes too. Speeding up. Okay. So black, red. Anybody catch that? Well, you should pause the video and tell me that you caught that before I did it. Before I caught it. Here we go. That makes much more sense. 6 out of 8 for black and 2 out of 8 for red. Okay. So let's go and just look at this one. I'm standing here. I pull a black card out. Now, I'm going to pull another one out. This second one, and let's just look at the black. If I pull the black out, there are only 7 cards left, and there are only 5 black ones left, just like I showed you from that bowl. So because I pulled it out, that black card stays out. Now the red cards, well, there's still 2 red cards in there because I haven't touched any, but there's only 7 cards left. So do you see how the denominators change, and for the black, the numerator changed because I have 1 less. Let's look at the bottom. Okay, so let's say I pull a red card out. Well, for the blacks, there's only 7 total cards left, and we still have the 6 black ones in there. For the red, there's only 1 red left because I just pulled it here out of 7 total. If you do not understand this, please come and see me so that I can go through it with you. Let's do the probability. 1 of each color is pulled, so let's look at the actual pathways. 1 of each color, so I need black and a red. So that's going to be 6 out of 8 times 2 out of 7. Or I'm going to have another pathway. I'm going to have red to black. So that's going to be 2 out of 8 plus 6 out of 7. All right, let's go through. 6 times 2, this is going to be 12 out of 56 plus 12 out of 56. This is 24 out of 56, which equals 0.43. Now, you could put the, if you want to do 12 out of 56 here and 12 out of 56, you totally could do that as well. Again, just another organizational tool. And the last one, first card is black given 1 of each color is pulled. So this is kind of like the last one. The denominator has to be the probability of 1 of each pulled, and we just did that, so I'm just going to transfer it down to my denominator. If you haven't done the denominator yet, you're going to have to do that extra step. So sometimes it might not just be and B. I made it work out here easy so that we could save a little time. So you might have to actually go and find that probability. So just be careful. All right, first card is black. So given 1 of each is pulled. So what we're going to have to do, first card is black. So that's this pathway here, and 1 of each. So that's here. So 12 out of 56 divided by 24 out of 56. The denominators cancel out. That's 12 over 24, which equals 0.50. So this has been with replacement, without replacement, and introduction to tree diagrams. A little bit long. Make sure you pause it. Try some out. This really comes with practice and setting them up. Call me over if you have some questions. Hope it helped. Thanks.